Why was the mermaid embarrassed? Because she lost her algebra. She lost her algebra. Boys and girls, welcome to our very first video lesson in our very first unit in Algebra 2, our lesson on compound inequalities. Okay, you should have your note packet out and you should be taking notes and filling in your note packet as you're going through this video. Please stop the tape whenever you need to and answer the questions as they come up. Here we go. Let's just review for a minute the steps to solving equations or linear inequalities. Okay, the steps are right here. Our first step is to always distribute. Do any distributing if there are any parentheses. If you have fractions, get a common denominator and write each of the terms in the equation or the inequality by the least common denominator to get rid of the fractions. Combine like terms on each side of the equal sign or the inequality sign. Move all the x terms to one side. And then we're going to get x by itself by performing our inverse operations, plus or minus, and then performing our inverse operations, multiply or divide. And of course, you know these steps from Algebra 1 and even pre-algebra back at Henry James. Okay, after we've solved for our inequality, we're going to have one of two options. We're going to either have a x is less than or x is greater than. And we know when we graph these, we graph it with an open dot. It doesn't include it in our answer. So here we have x is greater than -2. So down here in red, I have a graph of x is greater than -2, an open dot and everything to the right. And here we have less than or equal to or greater than or equal to is a solid dot, such as x is less than or equal to 1. So I have a solid dot here at 1. And I have everything to the left because it's less than. Okay, let's solve the following inequality. I'm going to subtract 5 from both sides. We see we have a minus or a plus 5. When I do that now, I get 3x is less than or equal to -9. Divide both sides by 3. Divide both sides by 3. I'm going to have x is less than or equal to -3. So I'm going to find -3 right here. I'm going to put a closed dot. And everything now to the left of that is in my solution. So there's the graph of my answer. And now let's do something new. Let's talk about writing this answer in interval notation. We have everything that is less than or equal to -3. So we have all the points now. Look here, we have all the points all the way down to -infinity. All the way up to and including -3. Let me write that -3 right there. So we have all the points from -infinity all the way up to and including 3. So I can write this in interval notation. That's going to look like I'm going to have a I need my marker. I'm going to have a parenthesis from -infinity, comma, 3, and then a bracket. Our answer is now from -infinity, let me get my pointer, -infinity up to 3. So whenever you have an answer that does not include this point, we have a parenthesis. And whenever we have an answer that includes that point, we're going to have a bracket. So this goes from -infinity to and including -3. And I need my negative sign right there. Sorry. Whoop. Okay, why don't you guys solve this one now for x? Just go ahead and solve this inequality. I'll be right back. I'm just going to go grab a cup of coffee. Okay, I hope you got an answer of x is less than -1. Did you have an answer of x is greater than -1? Did you forget to flip the sign when we divide by a negative? Okay, but I just subtracted the 4 from both sides, and I got -2x is greater than 2. So when I divide both sides by -2, I flipped my inequality, so I get x is less than -1. I'm now going to graph this. So I'm going to have an answer of -1 right here. I'm going to have an open dot, and I have everything to the left. Because once again, everything is less than, but not including -1. So when I write this in interval notation, my my solutions run from negative infinity all the way up to negative 1. And I'm going to close both of those with parentheses because it doesn't include those points. We can never reach negative infinity, so we don't put a bracket around that one. And we don't include the negative 1, so we put a parentheses around that one as well. Alrighty dighty, we just went through that interval notation real quickly, and I'll review it for you in a momentito. But let's go through our learning target here. I can solve and graph compound inequalities. So compound inequalities are basically just two inequalities in the same one. A compound inequality consists of two inequalities joined by an and or an or. So when we're writing our compound inequalities in interval notation, the word and means it must include both inequalities. That's the intersection sign, which is going to be that upside down U. And if we're doing an or, that's going to be the union sign. We use the word, or when we're using the word or, that's a union sign, a regular looking U. And whenever we're graphing these things, the graph of an and is going to be a segment between 2 points. It could be either closed or open dots. We don't know. But it could be either. It's going to be two segments. And the or typically is going to be two rays going away from each other. And again, they could be either open or closed dots, depending. Let's make one closed and one open. But that's what our graphs and our interval notations and our answers are going to look like. So looking right here, we have an example using the word and. All real numbers that are both greater than negative 2 and less than 3. So x is greater than negative 2 and x is less than 3. When we have the word and, I like to write it in 1, where basically x is in between negative 2 and 3. So negative 2 is less than x is less than 3. So to graph this thing, we're going to have, let me get my marker. We're going to have a point here at neg 2. We're going to have a spot here at 3. We're going to have two open dots because they are both less than but not equal to. And we're going to have all the points in between from negative 2 to 3. To write that in interval notation, I'm going to go from negative 2 to 3. And these are both going to be parentheses because they do not include the points negative 2 and 3. They're greater than negative 2 and less than 3. Okay, let's do this one together real quick. Practice numero uno. Negative 2x plus 5 is less than or equal to negative 8, and 2x plus 5 is less than 3. Let's solve both of these for x, so I'm going to subtract the 5. So I get neg 2x is, don't tell me, is less than or equal to negative 13. Divide by 2. Divide by, by negative 2. Divide by negative 2. So now my first answer, my first inequality is x is going to be, I'm going to flip-flop my sign, greater than or equal to negative 13, the positive 13 halves, which is 6.5. Let's look on the other side. I'm going to subtract 5 from both sides. So I have 2x is less than negative 2. Divide by 2. Divide by 2. X is going to be less than negative 1. So now, looking here, I have two inequalities, and my solutions must solve both of these. So x is going to be greater than 6.5, and x is going to be less than negative 1. So as I look at this, I have a negative 1 right here. I have a 6.5. I'll go back to blue over here. X is going to be greater than or equal to 6.5. Whoop. X is going to be less than negative 1. Notice that nothing here, there are no points that meet the criteria of both of those solutions. Both of those solutions. So therefore, I have no solution. In other words, x cannot be both less than negative 1 and greater than 6.5. I'm using the word and, so here we have an answer of no solution. Okay, I think these guys are actually fun. I'm writing my compound inequality in one inequality, but just with three parts, because negative 3 is less than or equal to 5x plus 7 is less than 17. So I'm going to solve for x right here in the middle, just like I would any other time, solve this for x. So basically, in all three spots, I'm going to subtract 7 and divide by 5. So I'm going to do that real quick. I'm going to subtract 7, subtract 7, subtract 7. So now I get negative 10 is less than or equal to 5x is less than 10. Divide everything by 5 to solve for x. Now I'm going to have here a compound inequality. Negative 2 is less than or equal to x is less than or equal to 2. So I'm going to put a point here at 2, a point here at neg 2. I'm going to have a closed dot at negative 2, an open dot at 2, because I had less than or equal to and less than. I'm going to fill in between because x is both greater than negative 2 and x is less than positive 2. To write this in interval notation, I'm going to go from negative 2 to 2. I have an open dot on the right-hand side, so that's a parenthesis, and I have a closed dot on the left-hand side, so that's a bracket. So this, in interval notation, once again means that x is greater than negative 2, up to 2, but not including 2. And there's my answer. Alrighty daddy, you guys try this one on your own, come up with a graph, and come up with an answer in interval notation, if you can. X is greater than 3, and x is less than 1. Okay, you should have found when you made your graphs, x is less than 1. X is less than 1, so we have an open dot at 1 and it points to the left. X is also greater than 3, so or greater than or equal to 3, so we have a closed dot at 3 and everything pointing to the right. Notice that x cannot be both of these. It can't be both less than 1 and greater than or equal to 3, so therefore we have no solution. However, let's just pretend for a moment that this was connected by not the word and, but by the word or. Now we have a compound inequality where this could be one or the other. So our graph is still going to look like this, but this time it works. This time it works. So basically what we can say here now is I have x can be less than 1. So we have from negative infinity, comma, up to 1, union, using the word and x goes from 3 up to positive infinity. So my answer in interval notation, if this had been or, would look like this down here in green. Okay, so that brings us to the second set of inequalities when we're using the word or. Okay, when we're using the word or, we're going to use an interval notation. We're going to use an interval notation, that union symbol, because it's one or the other. Remember, the intersection symbol is when we use the word and. So this is and, this is or. And of course, you know, or, it could be one or the other, does not have to be both. So all real numbers that are less than negative 3 or greater than 1 would look like this. And typically, we're going to have those ones where we have two rays. So we're going to have a spot here at 1, a spot here at neg 3. We're going to have open dot and everything to the left, open dot and everything to the right of 1. To write this in interval notation, on the left side I have negative infinity. Can't reach negative infinity up until but not including negative 3. Close with a parentheses. Union does not include 1. So we're going to go right here with a 1, comma, positive infinity up to infinity, but not including infinity, because infinity is just a concept. Alrighty. Okay, let's do this compound inequality using the word or right here, So first we're going to solve the left-hand side. I'm going to multiply this equation, or this inequality, by 5. I'm going to multiply each term by 5. Okay, so I'm going to have 5 times 2/5, of course, is just 2x. 2x plus 25 is less than or equal to negative 5. to subtract the 25. I'm now going to get 2x is less than or equal to negative 30. So my first one is, I'm going to write this here, x is less than or equal to negative 15. Over on the other side, real simply now, I'm going to minus the 5, x is going to be greater than negative 1. So right here at negative 1, down here at negative 15, I have a closed dot, whoop, heading to the left. X is less than or equal to negative 15. Negative 15. And to the right here, I have x is greater than negative 1, so open dot. In interval notation, you guys go ahead and write your answer in interval notation, and I'll be right back. Okay, you should have written, again, this is one of those ones where we have two rays going in opposite directions. They have, our left side is negative infinity, comma, negative 15. We have a parenthesis at around the negative infinity and a bracket because it includes the negative 15 and, or union, or parentheses, negative 1, that's an open dot, comma, infinity. Goes all the way up to infinity. Okay, let's do this one together real quick here. X is going to be less than 3 or union. X is greater than positive 1. So I'm going to mark up my number line here at 3, here at 1. X is going to be less than 3. X is going to be greater than or equal to 1. We're using the word or, so it's one or the other. You can see now that x actually can be just about anything. Any point on my number line meets that criteria. So my answer is all real numbers, which we can write in interval notation as negative infinity to infinity. All real numbers. Voila. If this had been an and, let's just pretend for a moment, if this had been an and, the only solutions that would have worked would have been right here in black, from 1 to negative to positive 3, not inclusive. And that, of course, in interval notation would be bracket 1, comma, 3, parentheses. Everything from 1 to 3, from 1 to 3, including 1, not. Alright, you guys try this problem. Just choose the multiple choice answer, A, B, C, D, that matches this graph up here. Choose the answer that matches this graph. Choose the answer that matches the graph. Okay, you should have found B is the correct answer right here, B, because x is going to be less than negative 3, or x is going to be greater than or equal to negative 1. Notice that we have the two rays going away from each other. We have to use the word or here. We can't use the word and because they can't be both. Okay, if we wanted to write this in interval notation, we're going to go from negative infinity up to negative 3. We're not including either of those. And then we union that, or x is going to be negative 1, including the negative 1, that's why I have a bracket, up to infinity. Alrighty daddy, we're just about done here, folks. You guys do this last problem on your own, and in fact, the first 5 people that email me the correct answer, it's got to be the correct answer, email me a compound inequality that answers this question, will get a bonus point on our algebra review quiz, the one that we are either just about to take or the one that we just took this week. Okay, so send me that email to my school email. First 5 people to get the correct answer get a bonus point on their quiz. That's it, folks. Have a great night, and we shall talk to you soon.